A team of astronomers from Yonsei University has presented an analysis pointing to a fundamental error in methods for measuring the expansion rate of the universe. If their conclusions are confirmed, we are in for a real revolution in cosmology, perhaps the biggest since we first heard about dark energy. For decades, Type Ia supernovae have served astronomers as a reliable tool for measuring distances between galaxies. They were considered so-called standard candles, i.e., objects with known brightness that allowed astronomers to determine how far away they were. However, it turns out that these stellar explosions are not as predictable as previously thought. Their brightness strongly depends on the age of the stars from which they originated. Younger stellar populations produce systematically dimmer supernovae, while those from older systems shine brighter, even after standard calibration. A team from Yonsei University confirmed this effect with remarkable accuracy of 99.999% by analyzing 300 host galaxies. This means that for years, astronomers may have misinterpreted both the distances to galaxies and the rate of expansion of the universe. The consequences of this discovery are far-reaching. When the correction related to the age of stars was taken into account, the data no longer fit the standard lambda-CDM cosmological model, which assumes the existence of a cosmological constant. The corrected observations are more consistent with the model preferred by the Dark Energy Spectroscopic Instrument Project, based on baryon acoustic oscillations, (BO), and cosmic microwave background data. Baryon acoustic oscillations are echoes of the Big Bang, sound waves that traveled through the early universe and left their mark on the distribution of galaxies. After combining the corrected supernova data with measurements of these oscillations and background radiation, the standard model was ruled out with overwhelming statistical significance. Everything indicates that dark energy is not a constant force, but is evolving much faster than anyone had expected. The most surprising conclusion from the study described in monthly notices of the Royal Astronomical Society suggests that the universe is no longer accelerating. According to the analysis, the cosmos has entered a phase of slowed expansion, which clearly contradicts the earlier findings of the DESI project. The difference results from the application of a correction for the age of stars. Interestingly, this conclusion is consistent with predictions based solely on baryonic acoustic oscillations or a combination of this data with background radiation. Dark energy, which is thought to make up about 70% of the universe, remains one of the greatest mysteries of modern science. After the Big Bang, gravity slowed down the expansion of the cosmos for billions of years. However, in 1998, astronomers discovered that 9 billion years after the birth of the universe, something began to accelerate it again. This mysterious force was called dark energy, although to this day no one knows what it actually is. Data from DESI in 2024 had already suggested that the force exerted by dark energy may vary over time. The new discovery goes even further, indicating that dark energy is not only evolving, but is already weakening enough for the universe to begin slowing down. What do you think about this? Comment, like, subscribe, share, support channel.